Today we're going to look over some of the facts associated with the straight line which were covered, a lot of which was covered at the National 5 level. So we'll run through these and see how we go. Horizontal lines, okay, have equations of the form y equals c. So you can see a horizontal line there, this red line going across wherever that is in the y-axis. The equation of that line is y equal whatever the y coordinate is. So possibly that one that's there in the diagram could be y equals 4, say, but there would be no x part attached to it. All points to the horizontal line have the same y coordinate. So a point to remember there with regards to horizontal lines. Vertical lines, this is where you've got your line going directly straight up and down. It doesn't deviate, so whatever the x value is, that's the equation of your line. So anywhere up and down this line is going to have the same x value. So the equation of that line is going to be x equal whatever. So this one could be k, could be 4, so the equation of that line would be x equals 4. All points of the vertical line have the same x coordinate. Okay. A third thing to remember is if you've got a line that passes through the y-intercept, so that's the point 0c, we can find the equation of that line using y equals mx plus c. M is always your gradient, c is this point where the line crosses the y-axis. So it's probably the most basic form of straight line, equation of a straight line. The next one is a point, doesn't have to cross through, or you don't need to know the y-intercept, any point on the line. And we know the gradient, we can find the equation of the line by using y minus b equals m times x minus a. So there shouldn't be anything new on this page here. Just a quick recap of some of the facts from National 5. So y minus b equals m times x minus a. Okay. So how does this help us solve problems? Remembering these things. So equation of a straight line. Looking at this example, to find the equation of the line with gradient 1/3 passing through the point 3 minus 4. So we know two bits of information there. We know that m is 1/3. We know that the point AB is 3 minus 4. So substituting that in, the formula y minus b equals m times x minus a gives you y plus 4 equals 1/3 x minus 3. Now we didn't really like leaving a fraction there, so we need to tidy it up, so we need to get rid of the fraction. So in this occasion we'd times the whole thing through by 3. So on the left hand side you'd get 3y plus 12, and on the right hand side you would just have x minus 3. Because you've multiplied by 3 and got rid of the fraction, you don't need to touch the bracket. You don't need to touch the bracket. You do still need to go to one more step to tidy it up. There's various ways you can do that. The first way, of course, is to get rid of 12 off each side. So take 12 away from each side and you'll be left with 3y on the left hand side, and you had x minus 3. If you take 12 away, you're going to be x minus 15. So that's one way to leave your solution. There's other versions that you may get which are perfectly fine. Okay, you may decide to rearrange that, divide it by 3, take it a step further, divide it by 3, so y equals 1/3 x minus 5, that's perfectly acceptable. Or some other versions that sometimes you end up doing is putting everything on the left hand side or the right hand side, making equal to 0. All these forms are correct. Okay. All these are going to be marked correct, but what you do need to do is make sure you tidy it up from the 3y plus 12 equals x minus 3. You need to do that extra step. Another example then, if we look at this one here, slightly different. We find the equation of a line passing through 2 points A and B. You're given the coordinates. So you've got a wee bit of work that you need to do here first, because the last example gave you the gradient. This time you need to work out the gradient before you can use your formula. So labelling A and B is x1, y1 and x2, y2. You use your gradient formula to get 1 minus 2 for your gradient, and minus 2 minus 3 in the bottom, and so on. So you get a gradient minus 1 over minus 5. Now we know what happens with fractions because we're dividing, so the two negatives make a positive, they cancel each other out. So the gradient you're looking for is 1/5. So on the right hand side here, we're taking the information. Any of your points A or B can be put into this formula. We're going to pick A because there's no negative there. So that saves us a wee bit of hassle, reduces your chance of making a silly arithmetical mistake. So if we pick A, it's 3, 2. Our values for A and B. We pick the gradient as being 1/5, which we've just found. Substituting that in, you end up with y minus 2 equals m times x minus a, which is 1/5 times x minus 3. So get rid of the 1/5, you times them by 5. So on the left hand side you've got 5y minus 10. And remember the right hand side, the brackets don't get touched because it's just the 1/5 you're getting rid of. So you've just got x minus 3. The next step is to tidy it up. Add 10 to each side, gives you 5y on the left hand side, and instead of x minus 3, you add 10, gives you x plus 7. Again, there's different ways you can rewrite that, you'll see down there on the right hand side. Another example to consider. So find the equation of a line with gradient minus 2/3 passing through minus 2, 7. So you're given a lot of information there, you're substituting it in. You notice right away you've got negatives there, and you need to take a wee bit extra care when you see a negative. So you substitute that in, and you get your mark for substituting in. Your A and your B has been minus 2 and 7, and your gradient has been minus 2/3, but you do need to be careful at the next step when it comes to your negatives. So in your brackets you had x minus minus 2, that changes to x plus 2. You want to get rid of your fractions, so you get rid of thirds by times them by 3. So you've got 3y minus 21 on the left hand side now, and on the right hand side you haven't touched the brackets, it's still x plus 2, but all you've done is get rid of the fraction, the third on the bottom. You're still left with minus 2 there in front of the brackets. It's really important that you remember that. So 3y minus 21 on the left, you multiply at the brackets on the right, times everything by the minus 2, minus 2x minus 4, and all that's left to do is tidy it up and put your numbers across on the right hand side. Add 21 to each side, that leaves you with 3y equals minus 2x plus 17. So slightly different type example because of the fraction there. This one here, now you have a line passing through the points minus 3/5, 4 and minus 3/5, 5. So the first thing you should be saying, well, the x coordinates are the same. So if the x coordinates are the same, then it must be a vertical line. If you plot them on your diagram, you see the two x's here, it's just a rough sketch, but every point in that line there is going to have an x coordinate of minus 3/5. So that is your answer. So not a lot of work needs to be done there, but you do need to recognise that situation when it comes up. This type here, it says extracting the gradient, so it's asked you to find the gradient, it's actually given you the equation this time, so you need to rearrange it so that we can work out what the gradient is. Now, in the writing there at the side next to the star, the red writing, says we need to rearrange it to y equals mx plus c in order to identify the gradient. So we're going to be doing a bit of manipulation, the letters and the numbers here. So we've got y on its own on the left hand side. So we need to get rid of the 3x and we need to get rid of the plus 4. So if we take 3x off one side, we've got to take off the other side. We've got a plus 4. If we take 4 off one side, we've got to take off the other side. So you've tidied it up a wee bit and it's left with 2y on the left hand side. And instead of 0, you've got minus 3x, you've got minus 4. We want a y on the left hand side, so we need to get rid of the 2. So we divide by 2. So it gets rid of the 2 and leaves us with y. But on the other side, we've still got to divide each of these things by 2, so minus 3x becomes minus 3 over 2x, and minus 4 becomes minus 4 over 2. Now minus 4 over 2, of course, minus 4 divided by 2 is just minus 2. So that's in the form y equals mx plus c. M is whatever's attached to the x, which in this case is the minus 3 over 2. So the gradient you're looking for is minus 3 over 2. Last example to try for today. So example 5a. Find the equation of a line passing through 5, 7 and parallel to the line with the equation 4x plus 2y minus 18 equals 0. Now we know that parallel lines have the same gradient, they have equal gradients. So what we need to do is, in order to find the equation of a line, we need a point in the line. We've got that at 5, 7. We also need a gradient. So we're going to have to rearrange 4x plus 2y minus 18 equals 0 into the form y equals mx plus c, just like the last example we did there. So, get everything across the right hand side that we need. We need the y's on the left and everything else across the right. So you need to take 4x away and you need to get rid of the minus 18. So you do the opposite and you would add 18. Then you're dividing by 2 to leave you with y on the left hand side. And on the right hand side, minus 4 becomes minus 2 and plus 18 becomes plus 9. Leaves you with a gradient of minus 2. The two lines are parallel, so they've both got the same gradient. So the gradient we are going to use is also minus 2. Of course, passing through the point in the question, which we were given has been 5, 7, it then becomes a reasonably straightforward substitute into y minus b equals m times x minus a, and then manipulate it, multiply it in brackets, there's no fractions there, happy days. Multiply it in brackets, get everything across the right hand side apart from the y, and that leaves you with y equals minus 2x plus 17. Agree there's a lot to go through there, lots of different types of examples. However, you've got this video, you can flick back and forward to it at your leisure. Okay.